Next one, energy. What is energy? Capacity of doing work by a body is called its energy. The body, by virtue, the body, the ability or capacity to do the work is called as what we call energy. Ability or capacity to do the work is called energy. It is a scalar quantity and its CGS unit is erg, SI unit joule. This unit taken on the honor of or respect of James Prescott Joule. James Prescott Joule, on the honor of James Prescott Joule. He was experimentally verified law of conservation of energy. Law of conservation of energy experimentally verified by James Prescott Joule. So on his honor, it expressed the Joule. It is the unit to express work, potential energy, kinetic energy, mechanical, etc. These are all expressed in the form of joules. The work energy, potential energy, kinetic energy, and mechanical energy. Energy, it is our are there. Heat energy, sound energy, potential energy, kinetic energy, mechanical energy, magnetic energy, electric energy, light energy, chemical energy. Like this, different forms of energies are there. Energy is available in different forms: heat, sound, potential, kinetic, mechanical, magnetic, electric, light, chemical, etc. Different forms of energies are there. Here, some important energies are, we have the different energies. They are, first of all, first one is potential energy, later kinetic energy, later mechanical energy. One by one we will see. First of all, here we have the some images. Mechanical energy. Mechanical energy, it is the summation of potential energy and kinetic energy. Sum of the two energies of potential and kinetic energy is called as mechanical energy. Right. So what is potential energy? What is mechanical energy? Let us see. First of all, first one, mechanical energy. Right now, various types of energies are there. In that, first one is potential energy. Potential energy represented with PE. What is potential energy? The body, by virtue of its state of position, is called as potential energy. The body, by virtue of or having of its state or position, that is said to be what we call potential energy. Potential energy PE is equal to mgh, where m is the mass, g is the gravity, h is the height, mass, gravity and height. These are the words in potential energy. So now the question is, what are the units to express the potential energy? What is the CGS unit to express the potential energy? Yes, erg. What is SI unit to express the potential energy? Joule. So joule is equal to how many x? 10 power 7 x. 1 erg is equal to 10 power minus 7 joules. Here, one question is there. Potential energy does not depends on option A, mass, option B, gravity, option C, height, option D, speed. Mass, gravity and mass, gravity, height and speed. So it usually depends on these three but doesn't depends on the speed. That is why our option is option D is the correct one. Previous examination question this is. What are the examples for potential energy? Example number 1, previous examination bit. Stored water in reservoir or overhead tank stored water in reservoir or overhead tank. Next. A boy sat on the tree lifted hammer stretched rubber compressed spring these are the next one. Compressed spring, stretched rubber. Next. A passenger in a vehicle which is at rest position passenger in a vehicle which is at rest position. Motion of the vehicle is 0. Vehicle is rest position, but passenger in the vehicle, he has the potential energy only. Yes, potential energy. Yes, like this, definition of potential energy, formula, examples, these are the next. One object is certain height, it has the potential energy. These are few examples for this one, potential energy. Next, kinetic energy, important one. What is meant by kinetic energy? Kinetic energy, it is defined as the body by virtue of its state of motion, important one. The body by virtue of or having of virtue of its state of motion the body by virtue of its state of motion is called as kinetic energy. Kinetic energy Ke is equal to half mv square, where m mass of the body, v speed of the body, here what is the relation between kinetic energy and mass, kinetic energy and speed? Let us see. We have the formula K is equal to half mv square in this, where v is constant. If let us suppose, if v is constant, relation between kinetic energy and mass is directly proportional, which means if mass of a body is increased, kinetic energy also increases in the case of v is constant. If mass is constant, kinetic energy Ke directly proportional to v square. If v is doubled, kinetic energy will be increases by 4 times. Important. Why? Because v is nothing but 2v whole square. 2v whole square is nothing but 4v square. 4v square, that is why kinetic energy will be increases by how many times? 4 times of its initial value. Like this, we have the relation in between kinetic energy and mass velocity. Next, if question, if a lorry and a car both are traveling with equal speed, which one has the more kinetic energy? Previous examination question this is also. If a lorry and a car both are traveling with equal speed, which one has the more kinetic energy? Right, where v is constant. Given options for this question: option A lorry only, option B car, option C both, option D none of these. C, V is constant, no? When V is constant, what is the relation between kinetic energy and mass? Directly proportional. In this, mass is increased, kinetic energy also increases. So that is why mass of the lorry is more than mass of the car. So that is why kinetic energy of the lorry is greater than kinetic energy of car. So answer is lorry has the more kinetic energy than car. Right. Next one. Next. This is the condition when V is constant, relation between kinetic energy and mass is directly proportional. Later. What are the examples for kinetic energy? This is the definition, formula, and conditions. Later examples. Running vehicle or moving vehicle. Running boy. Moving air. That is nothing but wind. Moving air is nothing but wind. Speed and direction of the wind measured with the speed and direction measured with Anemometer. Which of the following is used to measure the speed and direction of the wind? Repeated question. Speed and direction of the wind is measured with the anemometer. Altimeter, it is used to measure the altitudes. Altimeter, it is used to measure the height of the altitudes. Flowing water. Flowing rate of water. Flowing rate of water measured with the Venturi meter. Venturi meter, it works on the Bernoulli's principle. Venturi meter working principle is what is that? Bernoulli's principle. And moving objects have the kinetic energy. These are the examples for what is that? Kinetic energy. Relation in between kinetic energy and momentum. Kinetic energy Ke is equal to, we have the formula of mv square. It is multiplying and divided with m, which is equal to 1 by 2 m into m square v square by m, which is equal to 1 by 2m into m square v square is nothing but mv whole square 1 by 2m into mv whole square is nothing but p square. Therefore, kinetic energy Ke is equal to p square by 2m, 1 by 2m into p square or p square by 2m, both gives the same meaning. Okay, right. This is the relation in between kinetic energy and momentum. Relation between kinetic energy and momentum, K is equal to p square by 2m. Or this is also written has been like to Ke is equal to, we have the formula p square by 2m, which is equal to p square is equal to 2mke. P is equal to square root 2mke. Momentum P is equal to formula 2mke. Examiners will ask the question, either mass and kinetic energy mentioned, find out the momentum, or momentum and mass given and find out the kinetic energy. Right, like this examiners asking the question. One important question is there. Let us see. Question: if momentum of a body is doubled, momentum of a body is doubled, what happens the percent kinetic energy? If momentum of a body is doubled, find out the percentage of increase in kinetic energy. See, momentum P1 is equal to initial value P. Kinetic energy K1 is equal to K. P2 is equal to 2P. right? Then K2 is equal to, first of all, how much? Later we will find out the percentage of increase in kinetic energy. Therefore, K1 by K2 is equal to P1 square by P2 square. We have the formula, right? K1 is nothing but K, K2 is unknown value, P1 is nothing but P square, P2 is nothing but 2P whole square, which is equal to P square by 4P square. Here P square get cancelled, which is equal to 1 by 4. Therefore, K by K2 is equal to 1 by 4. Therefore, K2 is equal to 4K. So, moment, kinetic energy increases by how many times? 4 times. Right. What is the percentage of increase in kinetic energy is equal to change in kinetic energy by original kinetic energy or initial kinetic energy into 100. Change in kinetic energy, K2 is equal to 4K minus K by K into 100. 4K minus K, 3K by K into 100. See, KK get cancelled. 3 into 100, how much increases? 300% increase. If momentum of a body is doubled, find out the percentage of increase in kinetic energy. This is the question. We know P1 is equal to, as per the given information, P1 is equal to what is that? P. K1 is equal to K. P2 is equal to 2P. K2 is equal to how much? From relation between kinetic energy and momentum, K is equal to, we have the formula P square by 2M. From this formula, we can write like this. K1 by K2 is equal to P1 square by P2 square. K by K2 is equal to P square by 2P whole square. P square, 2P whole square is nothing but 4P square. P square cancel, 1 by 4. Then K2 is equal to 4K. Percentage of increase in kinetic energy, change in kinetic energy by original kinetic energy into 100. So 4K minus K, K2 is equal to 4K. K1 is nothing but K by K into 100. After simplification, we will get 300%. Next. If momentum of a body is increases by 100%, find out the percentage of kinetic energy. Percentage of kinetic energy is equal to 200 plus X by 100 into X. We have the formula. Percentage of kinetic energy is equal to 200 plus X by 100 into X. That is the formula. So right now here 200, what is the increasing value of percentage of momentum? 100% by 100 into 100, 100 get cancelled is equal to percentage of kinetic energy also increases by how much? Percentage of kinetic energy is equal to 300%. Like this, examiners asking the question, please concentrate. Next. Another question. If a lorry and a car both are traveling with momentum Which one has the more kinetic energy? If momentum of a lorry and car both are same, or lorry and car both are traveling with equal momentum, which one has more kinetic energy? That is the question. So here, how to find out this one? Kinetic energy Ke is equal to, we have the formula P square by 2m. In this, as per given condition, P is constant mentioned. Right now, kinetic energy Ke is inversely proportional to mass. Right here, already I think we discussed this. Right, relation between kinetic energy and mass is inversely proportional. So if mass is increased, kinetic energy will be decreases. Less mass of the body has more kinetic energy. If mass is less, kinetic energy is more. Right. So from this, less mass of the body has more kinetic energy. Therefore, kinetic energy of car is greater than kinetic energy of lorry. Kinetic energy of the car is greater than kinetic energy of lorry, because which one has more kinetic energy? When momentum is constant, car has more kinetic energy. In case, in K is equal to half mv square, in this V is constant, in that area Ke directly proportional to m. Here condition is important. Condition, as per the condition we can conclude, right? Ke directly proportional to m. Yes, if mass of the body increase, kinetic energy also increases. If mass is increased, kinetic energy also increases. That is why here mass of lorry is greater than mass of car. Therefore, kinetic energy of the lorry is greater than kinetic energy of car. This is right now. This is the way to find out the answers. So here lorry epudu when V is constant. Car has more kinetic energy when momentum is constant. Work energy theorem. What is work energy theorem? Let m is the mass of an object. Position of the object is A. It displaces from A to B. Initial speed of the object is u. Final speed of the object is v. Initial kinetic energy KEI. Final kinetic energy KEF. KEI is nothing but half mu square. KEF is nothing but half mv square. Therefore, work energy theorem, it is defined as change in the kinetic energy. Change in kinetic energy is called as work energy principle. Change in kinetic energy, it is nothing but final kinetic energy minus initial kinetic energy. Final kinetic energy of mv square minus of mu square. This is the work energy principle. It can as be like to of m into v square minus u square. This is work energy principle. WE is equal to half m into v square minus u square. Examiners framing the questions with respect to this formula also, please focus on it and try to simplify the numerical questions or numericals on this area. This is work energy principle. Next one, mechanical energy. How to define the mechanical energy? Mechanical energy, it is defined as, or windmill, certain height and in motion state. It consists of both bow and arrow also. It consists of the certain height and motion state. Mechanical energy. riding bicycle, clocks, aeroplane, seesaws, golf, swing, cranes, everything if it is certain height first of all and in motion state, that consists of the mechanical energy. This is potential energy already discussed. These are examples. Kinetic energy. Yes, already discussed these things. Law of conservation of energy before this. Here, one important thing is there, that is, rotatory ceiling fan has option A, only potential energy, option B, only kinetic energy, option C, both potential energy and kinetic energy, option D, potential energy plus rotatory kinetic energy. Which is correct one here? Potential energy plus rotatory kinetic energy. Why? Because it is certain height from the earth, rotates its own axis, that is why it has the potential energy and rotatory kinetic energy, not mechanical energy. In mechanical energy, object must be displaced from its position. But in this, there is no change. Ceiling fan. So position remains same, but it is rotating. Due to this one, what happens? Certain height from the ground. So potential energy. It rotates its own axis, rotatory kinetic energy. That is why we can conclude this like this.